Do you fully understand Google Cloud's unique identity and access management system, even for machine-to-machine authentication? In this video, you'll discover how to manage and use service accounts, roles, and permissions properly and efficiently. So, service accounts. These are often the bedrock of connections in Google Cloud. They can be constructed via the IAM and admin service, and a host of service accounts are automatically birthed for standard usage and management of Google Cloud Managed Services. Let's create an example service account together. We can add permissions to the service account during creation, but let's leave that untouched for now. These manually provisioned service accounts are in contrast to Google managed ones. For example, once Compute Engine is activated in this new project, we'll witness a new service account emerge. Again, this is a second breed of service account, the service accounts managed by Google to enable the operation of Google Cloud services. If we tread back to Compute Engine and attempt to spawn a VM, it will inquire about the service account. This common field is essentially a passport granting the specific instance or workload access to other Google Cloud territories. A crucial step indeed if we plan to tether our VM to a database, for example. Clicking the drop-down reveals both our service accounts, the one we manually created, and the Google Managed default service account for Compute Engine. By default, some permissions are auto-granted to the default service account. Over on the IAM page, you'll see the editor role has been bestowed upon the Compute Engine service account. Speaking of which, if you ever find yourself puzzled over permissions, the roles page is your guiding star. Search for Editor reveals a basic role. The detailed view shows that the role has about 8,000 permissions. For instance, if we navigate to BigQuery, there's a generous spread of BigQuery permissions, which we're applying to that service account at the project level. Meaning, this applies across all assets beneath the project. Craving a leaner permissions approach, we can accomplish that with trusty filters. After seeing built-in role candidates, we can add a new role to this Compute Engine default service account, let's say BigQuery admin permissions. IAM conditions let us stipulate conditions for that role, restricting it to certain schedules or specific resources, for instance. There's also an advanced condition editor where CEL expressions can be wielded. CEL, which simply stands for Common Expression Language, lets us specify IAM conditions. Here, you can wield a pretty high level of control over these permissions. But let's leave this for now and dive into BigQuery, where we'll explore simplifying the process by applying roles at the resource level for our service accounts. So, how about we create our dataset in BigQuery? If we zoom into this dataset and hit up the Permissions tab, we'll find ourselves with not just a bird's eye view of the resource permissions, but also a fast track to add either service accounts or users directly to this resource. So what have we done? We've shifted the conversation from project level permissions to resource level permissions. Let's bring our demo service account into the spotlight. All we need is the service account ID, then voila, we can assign it any roles we want. For instance, something like BigQuery Data Editor will work. Notice the shift here? We've now allocated this permission exclusively at the resource level as opposed to the whole project level. Sure, you could accomplish the same thing via IAM conditions, but with this approach, you're already working in the context of the resource, and the condition is built into the system for you. When dealing with resources, you might encounter a permission error when the service account roles don't align with the action you want to carry out. And this trouble can happen with user accounts too. Remember how we found permissions for a particular role? Let's flip it. we can find roles that fit the permission we're aiming for. Let's search for BigQuery datasets create and look at these roles that pop up. One example being BigQuery admin. The beauty of this approach is we can zero in on roles that better fit certain requirements. Let's not forget we can also create custom roles. Let's take a shot at creating one. We won't fuss much with the name and ID defaults. Let's rather observe how we can specify certain BigQuery-based permissions. Suppose we fancy the main permissions of a BigQuery admin, but want to dial it down a tad. This is how we do it. We assign just a fraction of those permissions. There we go. Our custom role is all cooked up, ready to be assigned to our service accounts and users. Let's change gears and discuss integrating our service accounts with our application code. The most straightforward route, albeit not often recommended, is generating keys for these service accounts. If we add a key right here and create it in JSON, we now have a way to employ this service account in our shell scripts or application code. But bear in mind, these keys don't expire by default. So, a quick piece of advice. Ensure you have an organizational policy in place for overriding that key expiration. This safety measure will help you maintain best practices around key rotation. Also, keep an eye out for other organizational policies which you can enforce at the project or organization level. For instance, you can disable service account key creation entirely, or even the automatic IAM grants for default service accounts. Remember the Compute Engine default service account we talked about earlier? You can rein in control over that using this organizational policy. Now let's put this all to the test with the Cloud function. That way we'll see how we can integrate service accounts without using keys. This is where Google Cloud's authentication mechanisms shine. When we select a service account and then hit Create, we get those roles and permissions, all without the headache of managing keys. For our test run, let's list every dataset in our project. Grab the Google Cloud BigQuery library and dive into our Cloud Functions code to replace the fixed response and show our datasets instead. Remember, we assigned BigQuery permissions to the service account for the one BigQuery dataset in the project. This should work, and we'll remove that permission afterwards to confirm. Let's give it a try, shall we? Without public access enabled, we need to play around with the command on the test system. So let's run this command in the Cloud Shell to test our function, all the while keeping a close eye on the evolving logs. Indeed, all looks good. We listed datasets using our demonstration service account, so let's yank that off and lose control over the resource. We'd now expect a change in the logs. If you're following along at lightning speed, note that you may encounter a time lag with the permission propagation. Give it a few minutes. After a patient wait, we're observing an empty list for the datasets, as expected. Remember, we have more than just the resource level for permission specification. We can also grant project-level access to datasets. Under the IAM page, Grant Access. The principal should be our service account, and for the role, it could be BigQuery admin. This will grant access across all datasets within the project. Let's test the waters again. Hopefully our access should resurface. Again, keep in mind the potential lag in permission propagation. Aha! We've regained access over that dataset. Ultimately, this is the way to go, and we should avoid service account keys. However, so far, we've only encountered Google Cloud authentication within Google Cloud itself. But what if we need to connect externally? There's two options here. The first is using OAuth systems organically with our Google user accounts. However, for simpler external connections, option 2, Workload Identity Federation, is often easier once you've tackled the initial setup. It's a bridge, joining the authentication between Google Cloud and other identity providers like AWS or other providers that leverage the OIDC protocol, like open source Keycloak. With this approach, there's no need for service account keys. One such system merges the role-based access control of both Kubernetes and Google Cloud. Let's dig into the Kubernetes engine to see this in action. We'll quickly create a cluster demonstrating how workload identity brings harmony between Kubernetes and Google Cloud's accounts roles and role bindings. Let's construct a cluster here using Autopilot. It's a more opinionated and managed flavor of GKE. If you prefer a standard Kubernetes cluster, just be sure to activate the workload identity setting. For our Autopilot cluster, that's enabled by default and is not optional. Primarily, we'll engage with this newly formed cluster via the console. Connect with the cluster using our CLI, thus setting up our kubectl client. Next, we'll create a conventional service account. We want to connect this demonstration Kubernetes service account with our formerly created demonstration Google service account. So we need to set up both sides of the bridge. On the Google side, we'll use the workload identity user role and integrate the IAM policy with the Google service account for seamless operations within Kubernetes. Moving forward to the Kubernetes side of things, we have to assign an annotation to our service account which points to the GCP service account. While we've swept through the work on both ends, note that there are command templates on standby within the documentation. Let's test out this new setup. We'll create a Kubernetes pod and use the Kubernetes service account to see whether we've successfully built that digital bridge. When we look at the test file, it reveals a pod specification leaning on the Kubernetes service account, aptly named demonstration. We'll then install the BigQuery library, just like we did in the Cloud function, followed by a quick list of our datasets. That's the sole function of this piece of Python code. Gear up as we apply this pod specification to our cluster while we keep an eye on the logs. First, we set up the BigQuery module, then we print out the datasets. Lo and behold, our demonstration dataset is front and center. We've accomplished bridging the identities from our Autopilot cluster. But wait, there's more. The workload identity system boasts further options. Navigate to that page in the IAM and admin service and broaden your connections to other identity systems such as OpenID Connect or AWS. We won't walk through this together today, but the fundamental concept revolves around building bridges across identity pools and generating mappings. We construct the pool, establish a bridge to the identity provider, create mappings, and grant access, a setup quite similar to our Kubernetes journey. The finale of today's chapter revolves around VPC Service Controls. To switch this feature on, you're required to shift to the organization's scope and establish an access policy. Having accomplished that, the world of perimeter control for GCP APIs opens up to you. In a nutshell, you're gifted a control gate around your service usage and the associated data. Simply add diverse projects and VPC networks, integrate Google Cloud Services, tweak the networking configuration, and proceed to set up ingress and egress rules to restrict your service and data usage. This approach permits control over where different identities and sources can be used or exposed. For instance, we may construct a perimeter where our BigQuery data in a project is solely consumable within that same project. This erects an extra layer of gatekeeping, protecting access to our GCP services and the underlying data. We'll keep an eye out for questions in the comment section. Many thanks for watching, and please enjoy responsibly.